This is Unit 2.7. In the last unit, we talked a lot about properties of equality. Remember, equality means equal sign, and these are a list of property of equalities. And for property of equalities, we're only talking about they have the same measurements. Usually it's expressed by a number. They have the same quantities, right? Those are more of algebraic concepts. And now we're going to talk about properties of congruence, and we use the congruence sign to represent it. And I'll shorthand it as property of congruence, POC. Okay? So let's look at the first one. Reflexive property of congruence. Basically, it's just like reflexive property of equality that I say segment, for any segment AB, AB is congruent to AB. Remember, I also called this the mirror property, right? Mirror property. Whatever you see in the mirror is whatever you get outside the mirror. Nothing more, nothing less. And symmetric property, you can probably guess that I keep touching places where I shouldn't be touching on my iPad. So if we say segment AB is congruent to segment CD, then we simply switch them. Segment CD is congruent to segment AB, and I call this the butterfly property of congruence. Because whatever is on one side is the same on the other side. You can switch the sides, but they're still the same. Transitive property, you probably know now. Transitive property of congruence is if segment AB is congruent to CD and line segment CD is congruent to EF, then I've got segment AB is congruent with the segment EF. Okay? It's rather self-explanatory, but when you have two tracks going, one track is equality, one track is congruence, their vocabulary is pretty much the same until the very last word. You really want to keep them filed away in two separate filing folders so that one doesn't interfere with the other. Just remember the difference is that properties of equality does not take shapes, sizes, thickness, those kind of three-dimensional things into account. It only talks about measurements or quantities. So next one, definition of congruence. Segments are congruent if and only if they have the same measure. So when we talk about segment, if AB is congruent to CD, line segments, then the measurement of AB is equal to the measurement of CD. And if two segments, line segments AB and CD measures the same, have the same measurements, then they are congruent. It's very intuitive, but you do have to spell it out. Definition of a midpoint. The midpoint of a segment divides the segment into two equal parts. So we can say if M is the midpoint of AB, then AM is equal to MB. Okay. Finally, there's this concept of postulate. Remember, postulate is an accepted statement without proof. So such as 1 + 1 = 2. We're not going to prove it, but we all know that is true, right? So here we have our first postulate, segment addition postulate, which states if A, B, C are collinear points, meaning remember collinear points, they're on the same line, and B is between A and C, then we can draw the conclusion that the line segment measure of AB plus BC, in other words, the length of it, equals the entire length of AC. So that is segment addition postulate. You have a practice sheet now. See if you can figure out some of these points. there is a, at the bottom of this sheet, there is a property bank. So you can use that as a guideline. So now is a good time to pause the video, finish your worksheet, and then come back and see what we're doing with this, okay? You can, when you finish, you can also open the keys, and if you don't want to listen to my explanation. So, but if you do want to listen to my explanation, here it is. First one, if PQ equals PQ, then PQ is congruent to PQ. So we went from equality to congruency, and nothing else has changed. So we know this is the definition of congruence. Remember, the reasons we list here can be definition, laws, postulate, theorems. Number 2, if K is between J and L, then JK plus KL is JL. This is segment addition postulate. Number 3, EF is congruent to EF. This is my mirror image and it's a congruency. Therefore, it's reflexive property of congruence. Number 4, if RS equals TU, then RS plus XY equals TU plus XY. First of all, it's an equal sign, so I'm talking about a property of equality. Secondly, all I did was I added the same thing on both sides, the same measure on both sides. So this would be an addition property of of equality. Number 5, if AB equals DE, then DE equals AB, right? Again, it's equal sign, so I've got property of equality, and all I did was I switched it around. Remember, that's my butterfly, so it's symmetric property of equality. Number 6, if Y is the midpoint of XZ, then XY equals YZ. This is simply the definition of midpoint. So some of the chapter 1 stuff are starting to come back. Number 7, if FG is congruent to HI and HI is congruent to JK, then FG is congruent to JK, right? Notice the connection here. So this is obviously a property of congruence. If A is congruent to B, B is congruent to C. So this is my A, this is my B, this is my C, and this is my D. So, oh, I'm sorry, this is, let me go back. So this is my B again, this is my C. So this is transitive property of congruence. Number 8, if AB plus CD equals EF plus CD, then AB equals EF. So it's obviously property of equality. And here, because it's plus, I have to minus CD, the length of CD on both sides. That's how I got to this conclusion. Therefore, this is a subtraction, right? Now let's look at number 9 on this page. If PQ plus RS equals TV, RS equals WX. RS is here. RS is here. Then PQ plus WX equals TV. So this is obviously a property of equality, and all they did was a substitution. Okay. Number 10, LP, if LP equals PN and LPN are collinear, meaning they're the same length, this on the same line, then P is the midpoint of LN. So this is number 10, and this is simply the definition of midpoint, which says that if a point is in between two collinear points, and it's equal distance to the endpoints, then you've got a midpoint. Number 11, UV, if UV is congruent to UV, then UV is equal UV equals UV. So this is definition of congruence. Yeah. And number 12, if CD plus DE equals CE, then CD equals CE minus DE. So all they did was they subtracted DE on both sides to cancel that one on the left-hand side. So this is a subtraction property of equality. Okay, so that's it for the second page, and I will see you guys back in class. Bye, guys.